Hi everybody, I figured I would let you actually see me in a video for once. Forgive the tie-dye t-shirt. I have been helping do some things around the house. But anyway, in the case of organic compounds, this is the second video I have in this series. And the first video introduced to you organic compounds and how we classify them according to their complexity, and how carbohydrates were first, and then then lipids, proteins, and nucleic acids. This video is going to focus on the second one in that group, which are your lipids. But we're going to start off with just a little bit of a review. So like I mentioned in the case of macromolecules, macromolecules are also called biomolecules. They are examples of organic molecules, which means they contain carbon. And carbohydrates, which you know of as sugars and starches, lipids, which you know of as fats, oils, and waxes, proteins, and the nucleic acids, things like DNA and RNA. And I mentioned how these are always listed in this order because they're listed according to their complexity. And when we talk about things being complex, that is referring to how many pieces does it have to make it up. So again, structure determines function, SDF. You can't understand how a car works unless you understand the pieces. And so in the case of carbohydrates, I introduced these things called monomers. Monomers would be like one Lego. It's like in this picture here, it's just one block. And monomers can't be changed. The only way I can change them is to crush them, is to destroy them. And so depending on how many monomers you have, when we start to put them together, you're going to make your polymers. Well, in the case of carbohydrates, carbohydrates were made from carbon, hydrogen, and oxygen. That's where they got their name from. And they were arranged in different ways in order to give them the properties of being sugars and starches. And again, in the case of your monomers, monomers were your simple sugars. Things like glucose, fructose, galactose. These are one single Lego. Mono means one. So you're just one Lego. And you know I can't pull a Lego apart. I can crush it, but that destroys it. And when I start clicking my Legos together, I can make these things called polymers. And depending on how many Legos you have, you get more and more and more complex. Well, in the case of lipids, which are your fats, oils, and waxes, and just so you'll know, fats are considered solid at room temperature. Oils are considered liquid at room temperature, and wax, like earwax, is kind of an in-between. It's kind of a mixture of the both. So in the case of lipids, just like carbohydrates are made from carbon, hydrogen, and oxygen, in the case of lipids, they're also made from carbon, hydrogen, oxygen. But if you think back to when we talked about carbohydrates, carbohydrates tend to be in a 1 to 2 to 1 ratio. For example, glucose is C6H12O6. The carbons and hydrogens are close or match, the carbon and the oxygens, and then the hydrogens kind of double. Well, in the case of lipids, lipids are made from the same three ingredients, carbon, hydrogen, and oxygen. But there is a lot of hydrogen, and there's a lot of carbon, but there's very, very, very little oxygen. So even though they have the same three parts, remember, structure determines function, the parts aren't in the same number, and we're going to arrange them differently. And one of the unique characteristics of lipids is that they're insoluble in water. If you remember, water is a polar covalent molecule, and it's what we call the universal solvent, which means it can dissolve pretty much anything except for lipids. You guys all know you try to mix oil and water together, the oil floats on top. Well, that's because lipids don't like water. Lipids and water aren't friends. And so we could say that lipids are insoluble to water. And in the case of lipids, lipids are incredibly important because without lipids, we would not be here. We would be a puddle of water on the floor. Our cell membrane, our plasma membrane, is made from lipids. And so it's basically like having this huge layer of fat surrounding, not my lamp over, surrounding the cell. And that's going to keep that cell from dissolving. So like I mentioned, in the case of our lipids, you can see here there's a lot of hydrogen. And there's a good amount of carbon, but there's very, very, very little oxygen. And we've been talking about Legos. We've been talking about monomers. Well, in the case of lipids, lipids are made from two monomers coming together to work together. One of the monomers is called glycerol. Okay. And if you remember that root word gly, that means sugar. So glycerol is actually a type of sugar. And again, remember 1 to 2 to 1 ratio. Notice there's 3 carbons, there's 3 oxygens, and then there's 8 hydrogens. So it's kind of a 1 to 2 to 1 ratio. Glycerol is a sugar. So that's one Lego that I need, or one color Lego that I need. And then I have these things called fatty acid chains. These are my fatty acid chains. This is the glycerol that they're attached to. So to make a lipid, I have to have 4 Legos. I need 1 Lego that's a glycerol, and then I need 3 Legos that are these things called fatty acid chains. Now, in the case of this picture, this just happens to be what we call a triglyceride. Glycer let you know it's a glycerol, and tri let you know that there's 3 fatty acid chains attached to it. And I know it's kind of cut off down here because of my picture, but you can see carbon, hydrogen, and not a lot of oxygen. This is why when people want to lose weight, they try to cut down on their carbs. They try to cut down on how much sugar that they have, because it takes a sugar to make a fat. Because remember, as animals, we cannot make sugar. So when we run out of sugar, we can't make more. So any sugar that's left over, our bodies want to save. And so our bodies turn it into fat. And fat is a little bit more complex than sugar. And in all honesty, nature plays a really dirty trick on us. Nature wants us to be fat. Nature wants us to have a little chunk on us. Nature wants us to have some chunk. That's why if you think about it, it's really easy to gain weight, but it's really hard to lose that weight because nature's going to fight you. Nature's like, no, I want you to have fat on you. Because think of all the things fat does for us. Fat keeps us warm. Fat protects our organs. And again, most importantly, every cell in nature has a layer of fat around it. And that layer of fat helps keep that cell from dissolving in water. Without that layer of fat, we wouldn't be here. So nature wants us to have fat. And in the case of our brain, you know, nature, we still have a part of our brain that's very primitive. It doesn't really know when our next meal is coming. So it makes you crave fatty foods. I mean, if you think about the foods that you crave, potato chips, French fries. I'm from the South. I love me some fried chicken and some mayonnaise. Okay, both very, very, very fatty. And so that's why if you ever do diets, they tell you to, cut out certain foods. They also tell you to cut out carbs because, again, as you can see here, it takes sugar to make a fat. But nature wants us to have fat in us. So nature played a dirty trick. That's why fat tastes really good. If you think about it, my shirt, I know you can't see, talks about bacon. I love bacon. Bacon is an animal fat. It's got a lot of animal fat in it. And so that's, a lot of people cook with animal fat. Again, I grew up in Alabama and in Virginia, and I can remember my great-grandmother had in her pantry this big blue metal can of lard, which is animal fat, Crisco. And that's what she would cook with. She would take a scoop of it and throw it in a frying pan. A lot of people cook with butter. Well, butter and lard are animal products, and they have more taste to them than something like an oil. Nature gave fat a taste because nature wants us to crave it. And that's why, like, if you drink Coke or Diet Coke, they taste different because they have different ingredients in them. If you have something like, again, I love mayonnaise. Mayonnaise versus low-fat mayonnaise. Low-fat mayonnaise is very watery. It doesn't taste the same. Think about ranch and low-fat ranch. Ranch is one of the #1 selling dressings, salad dressings on earth because it's got a lot of fat in it and people crave it. But anyway, kind of getting off subject, let's get back to the notes. So like I mentioned in the case of lipids, and a lipid is a fat, an oil, or a wax. And again, a fat is something that's considered solid at room temperature. So think about bacon grease, butter. Those are animal products. Oils are liquid at room temperature, which, vegetable oil, olive oil, those are plant products. And the waxes are kind of a combination. But a lot of times when people talk about lipids, they just use fats as the common word. But keep in mind, fat is just one kind of lipid. So like I mentioned, we all have a layer of fat under our body. And that layer of fat helps insulate us, it helps keep us warm, and it also helps protect our organs. And like I mentioned, it is the main molecule of the cell membrane. We are going to have a unit just on the plasma membrane, the cell membrane, and how it works, because it by itself is so important. And we're going to talk about all these different parts. But if you'll notice here, you have this little guy that has this round head on it, and it has this tail. It looks kind of like this. Okay. Well, this is a classic example of what's called a phospholipid. That's why it's called the phospholipid bilayer. The round part, the head, is the phosphate, and then those little squiggly lines, those tails, are lipids. And we actually have a bilayer, so we have 2 layers of lipids, and that helps kind of make a barrier around our cell, so our cell is able to maintain homeostasis. Our cell is able to, keep the bad things out and make sure that we get good things in, and it helps keep us from dissolving. So the number 1 type of lipid in nature is what's found in phospholipids. It is a triglyceride, and every cell in nature has a plasma membrane. And to be a plasma membrane, you have to have these phospholipids in it. Incredibly, incredibly, incredibly important. And also, some lipids make up hormones. Now, hormones are probably a term that you've heard a lot in your life, but you might not really quite know what a hormone is. And when your brain needs to talk to your parts of the body, it makes electricity. But think about it, not everything has a brain. And so, for example, how do the leaves of a plant talk to the roots? Or how does your stomach talk to your large intestine? We make hormones, and hormones are chemicals that we use in order to allow cells to talk with each other. And some of the hormones that our bodies make, things like testosterone, estrogen, progesterone, these are steroids. Anytime you see steroids, steroid is a hormone made from a lipid. So like I was saying, these are just some examples of different lipids that we have in nature. We have steroids, things like cholesterol, chlorophyll, the different sex hormones, estrogen, progesterone, testosterone. Those phospholipids we talked about that make up our cell membranes, our cells would dissolve without them. And then in the case of lipids, fats are our main examples. They're made of glycerol and 3 fatty acid chains, which is what you're seeing in this picture here. Again, you have your glycerol, and you have your 3 fatty acids. Now, in this picture, notice that the carbons are completely filled up. There's no room. Every carbon has a hydrogen attached to it in this in this picture here. Okay. That's what's called a saturated fat. If something is saturated, that means it's full. It doesn't have room for anything else. And animals make saturated fats. That's why it's like we build bricks and we stack those bricks on top of each other, and it makes things solid. Well, oils are missing a hydrogen in there somewhere. So let me erase this. So in the case of an oil, it would be like this hydrogen is gone, or this hydrogen is gone. And there's a gap there, there's a space there. That's what's called an unsaturated fat. An unsaturated fat would be like having a brick wall that has openings in it. Plants, oils, are unsaturated. That's why they're liquids, they're fluid. And that's why unsaturated fats are better for us than saturated fats, because they're easier for our body to break down. That's why doctors tell us that we should cook with things like oil instead of butter or bacon grease. And so again, just different functions that lipids have. Long-term energy storage. Again, our bodies want us to save lipids. They want us to save those fats so that we can use them if we don't get the nutrition that we need, if we have to go into like a mini starvation mode. And even though they have the same 3, carbon, hydrogen, and oxygen, their bonds are different and their bonds are stronger. So it takes our body longer to break it down. Again, think about it. It's really hard for our bodies to lose weight. At the same time, it's going to help protect us. It's going to help insulate us. And like I was mentioning, you do have 2 types of fats. Saturated fats are made by animals, and they are solid at room temperature. It's like just taking a bunch of Legos and stacking them on top of each other and making a brick wall. Okay? There's no gaps inside of it. The bonds are full. And so butter, bacon grease, things like that. Unsaturated are liquid at room temperature. It'd be like you making Legos, but when you stack them up, you leave little gaps in there. And this is easier for nature to break down. And this is why they taste different. If you ever have butter and margarine, butter is animal fat. Margarine is what I call fake butter. It's made from plant oil. And they taste different. That's why, can't believe it's butter. I think it's margarine. And they've added chemicals to it to make it taste like real butter. And so with saturated fats, again, I cook with bacon grease. I cook with butter. I love mayonnaise. I love fried chicken. I love donuts. I'm getting hungry. Okay? We crave fatty foods because nature wants us to have this insulated protection. Nature wants to make sure our cells have that layer of phospholipids around them. So saturated again means that they have all the bonds that they can hold, and something that's unsaturated means it has a few spaces in between it. If it's saturated, it's made by an animal. If it's unsaturated, it's made by a plant, which is why in the very beginning, when this whole health craze started, people didn't realize the difference between saturated and unsaturated. And so different oil companies were actually blamed for price gouging because they would make vegetable oil and they put it in this bottle and they would have a white label on it and it would say vegetable oil and they maybe charged $1. But then right next to it was the same size bottle. The oil was the same color, but the label was blue and it said unsaturated vegetable oil and they charged $2 for it. And that's because consumers didn't realize it's the same oil. They had just heard that it was better for them to have unsaturated oil, so that's what they went to buy.